This video comes from a hole I dug myself into. For a while now, I felt like Claude Code has been getting worse in my workflow. It ignores instructions, contradicts itself across long outputs, and makes basic mistakes it never used to make. If you're using Claude Code and you felt the same thing recently, watch this all the way through. I'll walk you through exactly what I hit, how I tracked it down, and what actually fixed it. Let me describe what I was seeing. I run an unattended workflow on Claude Code, no human in the loop. And lately, I'd write explicit "do not do X" rules in my prompt, and it would do X anyway. Design specs with dozens of constraints, it'd follow maybe half. Long outputs where the model would reference the first two when it meant the last two, just contradicting itself. Same prompt, wildly different outputs run to run. I was convinced Opus 4.7 had been quietly nerfed. Plenty of people in the community were saying the same thing, so I figured I'd found my answer. Then I checked one file in my project, and the whole story changed. I opened the memory file Claude Code loads at startup. Claude Code automatically loads a file called CLAUDE.md as a persistent system prompt every time it starts. In my project, that file, plus the memory.md it was importing, came out to 31.5 kilobytes. That number probably doesn't mean much on its own, so let me translate it. 31.5 thousand of text is roughly 8,000 to 10,000 tokens. Every single turn of the conversation, the model was carrying that 10,000 token payload into its reasoning. Opus 4.7 has a 200,000 context window, which sounds enormous. But the effective attention window is much smaller than the advertised size. There's a well-documented phenomenon called lost in the middle. Models pay strong attention to information at the beginning and end of their context, and information stuck in the middle gets significantly diluted. My 31.5K memory file was packed with sediment. Outdated rules, notes about problems I'd already solved months ago, conventions I'd long since abandoned. None of it had been cleaned up. All of it was eating into the model's attention budget on every single turn. So what was actually happening? The model was splitting its focus between absorbing 10,000 tokens of historical baggage and executing the specific task I just asked for. I thought it was concentrating on my instructions. Most of its brain was actually busy parsing junk that shouldn't have existed anymore. That was the source of the dumbness I'd been feeling. Anthropic hadn't quietly weakened the model. I had polluted my own context until the model couldn't see straight. A note here, because this tripped me up at first, and it trips up a lot of people. Claude.md is the official memory file Claude Code loads automatically at startup. It searches in a hierarchy and merges everything it finds. There's enterprise level, which is a system-wide configuration directory. There's project level, which sits in your working directory. This is the most commonly used one. It gets committed with the repo shared across the team. There's user level in your home directory under .claude. These are your personal preferences, applied across every project. And Claude Code also walks up the directory tree, so in a mono-repo, subprojects inherit rules from the root. All of these get merged into one big system prompt at startup. Memory.md, on the other hand, is not automatically loaded. It only ends up in the model's context if your Claude.md explicitly imports it using the @ import syntax. Some community frameworks and plugins use this pattern. That's how mine got there in the first place, and I didn't even realize it for months. If you're not sure what's actually being loaded in your project, run /memory inside Claude Code. It'll show you every file currently active. Don't guess, check. One more thing worth knowing, and this is where a lot of people accidentally blow up their context. The @import expansions happen at load time, not on demand. If your Claude.md imports 5 files, all 5 get fully expanded and stitched into the system prompt up front. they're not lazy loaded when needed. So a small 1K Claude.md that imports 5 6K reference docs is actually a 31K memory payload on every turn. The file you're editing looks innocent. The actual context the model sees is monstrous. This is exactly how my project ended up at 31.5K without me noticing. The visible Claude.md was tiny. The imports were the killers. The lesson here? Don't measure your memory by the file you edit. Measure it by what /memory actually reports as loaded. I want to spend a minute on something most people get wrong. Most people only think about context size in terms of speed and price. The quality cost is bigger than either, and it's invisible. 3 things happen as your context grows. First, attention dilution. A model's attention isn't infinite. It's a finite budget, distributed across every token in the context. With 2K of context, every token in your critical rule gets a lot of attention. With 30,000 of context, the same rule gets a small fraction of the attention. The rule didn't change. The model didn't change. The attention each token gets shrank. This is why people see the exact same prompt produce great results in a fresh session and mediocre results in a long one. Nothing changed except the surrounding noise. Second, position decay. Even within the available attention, distribution is uneven. The beginning and end of the context get the strongest signal. The middle gets the weakest. That's the lost in the middle effect I mentioned earlier. When your memory file is small, almost everything lives in the edges. When it grows past 10,000, more and more of it falls into the dead zone in the middle. Critical rules buried in there might as well not exist. Third, instruction competition. This one is subtle but maybe the most important. Every instruction in your context is implicitly competing with every other instruction for the model's compliance. When you have 20 rules, they coexist fine. When you have 200 rules, many of them outdated, several contradicting each other, the model has to silently pick winners. You don't see this happening. You just see it ignored my rule, and you blame the model. It didn't ignore your rule. It picked a different rule that was also in the context, often one you forgot was even there. The practical takeaway. When you're deciding whether to add something to your memory file, the right question isn't, is this useful? It's, is this more useful than the cost of diluting everything else? Most additions fail that test. Most memory files should be shrinking over time, not growing. I now treat my memory file the way good engineers treat dependencies. Every addition is a liability. Every line earns its place or gets cut. A quick detour into why context volume hits model performance so hard. Large language models work with a fixed attention budget. The more information you feed in, the smaller the share each individual piece of information gets. Picture walking into a meeting. 5 documents on the table. You can read each one carefully. 50 documents. You skim titles. 500 documents. You give up and just go with your gut. Models do the same thing. Cram 31.5 kilobytes of memory into the system prompt, and the specific instructions for your current task drown in a sea of historical context. It gets worse. Most memory file content is written as soft constraints. Things like, prefer this approach, usually do that. That kind of language already carries lower weight than direct commands. Diluted across a massive context, and the model is essentially operating on vibes about the project instead of executing your actual requirements. Memory files aren't better when they're bigger. The concentration of critical rules matters far more than the total volume. Some rough numbers from my own testing. Under 2K is ideal. Almost everything gets followed. Under 5K is solid. Critical rules in the right positions stay reliable. Above 10K, noticeable degradation starts. Above 20K, severe degradation. Instruction following drops visibly in long sessions. Above 30,000, your workflow is running on borrowed time. Mine was 31.5 thousand. Critical condition. Worth talking about subagents here. A lot of people use Claude Code with just the main agent. Every task piles into one session. That's fine for simple cases, but once your workflow gets complex, running everything in one agent is a disaster waiting to happen. Subagents are the only mechanism in Claude Code that gives you real context isolation. Each subagent has its own system prompt, its own context window, even its own tool permissions. What that buys you? The main agent handles orchestration and carries the project-wide rules from Claude.md. But the subagents that actually execute subtasks can load only the minimum context they need for their specific job. A code generation subagent doesn't need deployment rules. A code review subagent doesn't need the full style guide. Each subagent operates in a high-focus environment where its attention isn't fragmented. Subagents also make great independent verifiers. Have one subagent generate code. Have a separate subagent with a completely independent context review it. The reviewer hasn't been contaminated by the generator's reasoning path, so it catches problems the original would never flag. Running a single agent with a giant Claude.md is double contamination. Bloated, polluted context with no independent perspective to catch errors. After today's deep dive, I put together a checklist, ranked by priority. 1. Check your memory file size right now. In Claude Code, run /memory to see what files are actually being loaded. Then run wc-c on each one. Any memory file over 10K is a likely contamination source. 2. Put your memory files on a diet. Sort the contents into 3 buckets. Core constraints, which are hard rules, prohibitions, and critical conventions. Keep these. Reference material, like architecture docs, API docs, long background. Move these to separate files and have Claude read them on demand with the read tool. Don't keep them resident. Stale content, like deprecated rules and problems you've already solved. Delete these. Target a Claude.md of 2 to 5K. Anything over 5K triggers a review. 3. Layer by position. Beginning and end of the memory file carry the most weight. Put your most critical prohibitions at the top, your most critical required behaviors at the bottom. Background and context go in the middle. You're working with the lost in the middle effect instead of against it. 4. Hard constraints belong in settings.json, not memory. Rules that absolutely cannot be violated go in .claude/settings.json under permissions.deny. Block rm-rf, block pushes to main, whatever you can't afford to have violated. Claude Code enforces these at the tool call level. It does not rely on the model behaving. For an unattended workflow, this is your last safety net. 5. Complex workflows must use subagents. Split by responsibility. Orchestration, generation, review, testing. Each subagent gets its own focused context, its own tight prompt, and the minimum permissions it needs. 6. Add hooks for automatic verification at critical points. Claude Code supports pre-tool use, post-tool use, and stop hooks that run scripts automatically around tool calls. Run lint and tests after code changes. Auto-reject and retry on failure. Build the verifier into the workflow. Don't trust the model to verify itself. 7. Set a maintenance rhythm. Review memory files every 2 weeks. Watch the size. Content added via the hash shortcut needs periodic cleanup. A project running for 6 months with no memory cleanup is a project waiting to fail.